Okay, so today we'll be talking about paper 2. This is from St. Benedict's, their 2020 prelim papers. We'll be covering section A today. So let's get into it. Let's just dive straight into it. Yeah, so from the first question. Okay, question 1. So this question says 14 learners who had no access to technology during lockdown attended the geometry training course, spread over 12 Saturdays to make up for the work they missed during COVID-19. The learners wrote a COVID test at the end of the course, and one learner was absent for the test due to contracting the virus. The number of Saturdays attended and the mark as a percentage of each learners obtained for the test are shown in the table below. Okay. These are each of your 13 learners. So the first learner attended 12 Saturdays and had 96. This learner attended 11 Saturdays, had 91, and so on until the 13th learner here, which attended 6 Saturdays, had 59. The question wants us to calculate the correlation coefficient, right? To find the correlation coefficient, we need to use our calculator, okay? So let's bring up our calculator right now. So to get your correlation coefficient, we go to modes, we go to stats, then we go to a plus bx, that's 2. Then we just need to input these values, right? So we have 12. Okay, so these are all your 13 values now. After we do that, we press the AC button, we go to shift, we press start, then regression. This is 5, okay? And we press 3. The correlation coefficient is represented as R, so I press R, which is 0.92. The correlation coefficient is 0.92. That would be your value for R. Okay. Now they ask to comment on the strength of the relationship between the variables. Because your correlation coefficient is positive, the first comment would be that it is positive. Also, because it is greater than 0.9, we can say that it's strong. And because it's very close to 1, we could also say it is linear correlation. Okay, so this is the strength on the relationship between the variable. It is positive, it is strong, it is a linear correlation. Okay, then C asks us to calculate the equation of the least square regression line. Now to find this, the equation of our least square regression line looks like this. Y is equals to A plus BX. So we need to get what A is, and we also need to get what B is. We are also going to use our calculator. So let's go back to our calculator. Okay, so we press the AC button again, we go to shift, we go to 1, we go to 5, and that's your A, that's your B. See, 1 is A, B is 2, so we substitute 1, there you go, 22.26. So this A is 22.26, then for B, we do the same thing, 22.26, we're going to go back again for B, shift, start, reg 2. So B is 5,898. So that's 5,898. So writing it properly, it is Y is equals to 22,26 plus 5,9x. Okay, so this would be your equation of your least square regression line. We go to D. D says the learner who was absent for the test attended the course on 8 Saturdays. Okay, predict the mark that this learner would have scored for the test. Now, we just need to substitute 8 into this equation. So we have Y is equals to 22,26 plus 5,9. Then we substitute 8. Let's put this in our calculator. 22,26 plus 5.9. Then we have 8. Now we have this answer as 69,46, which can just be approximated as 69%. Okay, that's it. Now 2 asks us to discuss how reliable this result is. We can say that the result is fairly reliable. Yeah, it is fairly reliable. And the reason why we say it is fairly reliable is because the data was interpolated. So we can say our data was interpolated. And what that means is our value, which is 8, lies between our set of data points, right? Our data point for Saturdays was from 4 to 12, and what we're trying to get was 8. So since it falls within our set of data points, we can say that it is fairly reliable. If it is outside the data point, we'll say it is extrapolated, and that is not really reliable. But for this, it is reliable. Now, E says, once the sick learner was granted permission by his doctor, he came in during the next week to write the test. The class average changed to 71%, determined the mark that the learner attained. Okay, so we can say let X be the mark of the absent learner. Okay, so now what we need to do is we need to first of all get what is the total marks for all 13 learners that we had, right? The total mark for all 13 learners, we're going to use our calculator. We can also use the same data point, right? We'll go to shift 1. Now we'll go to sum 3. Now we go to Y, which is 4, because that captures the data for the marks. That's 950. Now, if you add all the marks of the 13 learners, it gives you 950. Now, plus X over 14. So the reason why I'm doing this is because I'm trying to get the mean. Now, to get my mean, I need to add the mark of all the 14 learners. Now, this 950 is for the 13 learners that we already calculated, and this X is for our learner that was absent. Now, we have to divide it by the total amount of learners now, which is 14, and it should be equals to 71, right? So cross multiplying, we can say that 950 plus X is equals to, so you say 914 times 71, which gives you 994. So therefore, X is equals to 950, 44%. So the 14th learner should have an average of 44%. That's it. So in question 2, this here says in the figure below, 2 circles with the center M and P respectively are drawn. The equation of circle M is x plus 2 squared plus y minus 1 squared is equals to r squared. Now S, which is 1 and negative 2, is a point on both circles. SR, yeah, this line over here, is a tangent to both circles, and P has a coordinate A and B. So A says the first question asks us to write down the coordinate of M. Now M is the coordinate of the circle, right? And we normally get it from here. Now the equation of a circle when the center is not at the origin actually looks like this. This is x minus a squared plus y minus b squared. So we can say that our a would be -2 from here, which is our x coordinate, and our b would be +1 from there. Okay, so our coordinate will be -2 and 1. Now for b, it asks us to determine the value for r, the radius of the circle M in simplified third form. So we just need to rewrite our equation. So this equation here is x plus 2 squared y minus 1 squared is equals to r squared. We also know the point S is on the small circle. Now, since the coordinate on the small circle, we can substitute it into our equation and it will help us get r, right? So the coordinate is 1 and -2. Okay, so I'm going to substitute 1 and -2 into that equation. So if I substitute that, is what I'm going to get. It's 9 squared, r squared is equals to 18. To get r, we just need to square root it. So square root of 18 gives you 3√2. So we can say our radius is 3√2 units. Now C says determine the equation of the tangent SR in the form of y is equals to mx plus c. Okay. Now for you to get the equation of this tangent, this SR here, we will need the gradient and we'll need a coordinate. Now we do have the coordinate of S here. That's very important in helping us get this equation. But we don't have the gradient. And we don't have 2 points on this line to help us get the gradient. However, our radius is always perpendicular to a tangent. So if I can get the gradient of MS, I could get the gradient of SR because they'll be perpendicular to themselves, right? The gradients will multiply to give you -1. Okay, so let's try to get the gradient of MS, and this is what that's going to give you. So we understand the gradient of MS times the gradient of SR would give you -1. So now if the gradient of MS is -1, therefore the gradient of SR will just be 1. Okay, so we can substitute this gradient and the coordinate of S, which is 1 and -2, 1 and -2, into our straight line equation. So the equation of our tangent will be y is equals to x minus 3. So given that MS ratio MP is equals to 1:4, determine the values of A and B. Okay, so we're going to be answering this question on our circle over here. Now we're told that the ratio of MS to MP is 1:4. So I'm going to say that this here is 1. And I'm also going to say this here is 3. I'm saying this is 3 because this entire length is 4. So this part will just be 3. Now that's not the distance, it's just a ratio. So we can put a variable next to it so that we understand that that's not the actual values. Okay. Now what I'm also going to do is that I'm going to create a right angle triangle. So I'm doing this so that it can help me find my value here for P. So I'm saying this, that if I create a right angle triangle here, so this will be parallel to the x-axis. So I draw a straight line and I also draw a straight line here. Now from here, I would understand that since the coordinate of M is -2 and 1, this is 90 degrees. If this is a horizontal line, the y coordinate would also be the same. So the coordinate for this would be 1 and 1. So that will mean that the distance here is 3 and the distance here is also 3, right? Now if we construct the second part, yeah, so if we construct a right angle triangle for MP, is going to look like this. Yeah, continuing in that same vein. Okay, yeah, that is also 90 degrees. So that is also a horizontal line. The y coordinate doesn't change, just the x. Now, if the ratio is 1 to 4, it will mean that if the distance here is 3, the whole distance here would have to be 12. Okay, so it would actually mean that it is going to be 12 units to the right. The y will still be 1. However, the x would be 10 because it is 12 units after -2. Okay, now we'll do the same thing for the y. The ratio here is 3. So the ratio here would also be 12. So you have to have 12 units downwards, right? So this here is 10 and 1. So if it's moving 12 units downwards, A will still be 10, but B will be 11, -11. And that will be your answers. And that's exactly how they needed you to answer this question. And the last question, question 2 here says, determine the equation of the circle P. Now, this circle P over here has a center of 10 and -11. We know that the radius of MS is 3√2. We got that in the previous question. So the radius here, because it is 3 times that, it will be 3 times 3√2, which makes it 9√2. Okay, so that's your radius. So the coordinate is 10 and -11, and the radius is 9√2. So now putting all that in, this is what you're going to get. X minus 10 squared plus y plus 11 squared is equals to 9√2 squared, which, as you know, that's the same. However, this would give you 9√2 close brackets squared, 162. There you go, 162. And that there will be the equation of your circle P. That's it. Question 3. So now this question says, given that sine 40 cos 22 plus cos 40 sine 22 is equals to k. Determine without the use of the calculator the value of the following in terms of k. Okay, so the first question here says sine 62. We need to find sine 62. Now looking back at our question, we understand that this here is a compound identity. I understand it's a compound identity because this represents A, this represents B, this represents A, this represents B. So it's the sign compound identity where if this is a plus, this here would be sine A plus B. If that's the case, our question over here can be written as sine 40 plus 22. And as you know, sine 40 plus 22 gives you 62. And this whole thing, if this whole thing is k, it means that sine 62 is actually equals to k. Now the next question wants us to find tan 118. With this question, the best approach is reduction formula. So we're going to reduce this. Since this is in the second quadrant, it can be written as tan. And tan in the second quadrant is negative. So this here can also be written as negative tan 62. So now we need to figure out what tan 62 is. From trig ratios, tan theta is y over x. Now, if we want to figure out what tan 62 is, we could also figure out also y over x. But the problem is we have y, but we do not have x. Now, how we do have y is this. Now, sine 62 is the same thing as k, which can also be written as k over 1, which makes ky and r 1. So we need to figure out what x is. To find x, what we can do is that we can say r squared is equals to x squared plus y squared. Now substituting the values of k and 1 into this Pythagoras, we can get 1 squared is equals to x squared plus k squared. And in so doing, x is equals to the square root of 1 minus k squared. Now that you have y, which is k, and we just figure out what x is, which is the root of 1 minus k squared. With this, we can now say what tan 62 is, because it's also going to give us y over x, right? So in that case here, it will be k over the root of 1 minus k squared. And that will be your answer. Question 3 says sine 14 cos 14. And this looks very similar to double angle identities. Now, double angle identities for sine looks like this. Yeah, where you have 2 sine A cos A. Yeah, this is sine 2A. Yeah, but the difference here is that we do not have that 2 before it. But we can actually put this 2 so that we can tap into this double angle identity. But now for us to do that, we have to balance it out by multiplying a half so that a half cancels the 2. So this here can be written as half times 2 sine 14 cos 14. Now this is a sine double angle identity. Now this here would give you sine 28. And since we need cos 62, now sine 28 can be changed into cos 62 due to co-ratios, right? So this here can be written as sine 90 minus 62, right? Because 90 minus 62 is 28. And sine 90 minus 62 due to cofactors is cos 62. And cos 62 we got in the previous question to be equals to k. So your answer is just half k. And that's it. B. So simplify the following expression. So this expression is cos 90 plus x, sine x minus 180, negative cos squared 180 minus x, all over cos negative 2x. All this is added to sine squared x. Okay. To answer this, the first thing I'm going to do is draw the quadrant. Now I'm drawing the quadrant to help me remember all the identities necessary to calculate this question, right? This is all, here's positive, that's sine, that's tan, that's cos. Now for the positive quadrant, we consider this theta, this is 180 minus theta, this is 180 plus theta, this is 360 minus theta. Whenever you have the negative quadrant, it looks like this. This is negative theta, this is theta minus 180, this is negative theta, negative 180, and this here is theta minus 360. For cofactors or cofunctions, this here is 90 minus theta, and this here is 90 plus theta, right? So we can use each and every one of these identities to help us reduce our expression, okay? So the first one here says cos 90 plus x. Now this is cofactors, and 90 plus theta is in the second quadrant, right? And 90 plus theta in the second quadrant would mean that this would have an overall negative sign, right? However, with cofactors, cos always changes to sine, so this here would actually be negative sine x times. Now we have x minus 180 is part of the negative quadrant here, which is theta minus 180. It is negative for this, so since it is sine, and sine is negative in the third quadrant, this can be written as negative sine x. We have minus. Then we look through this one here. This is 180 minus x, but there is a squared here. So it's best to look at this, that you rewrite this expression as cos. Yeah, and the squared is outside here. Now, if the squared is outside like this, whatever I have inside the bracket, I can square it after I'm done. Now, 180 minus x is in the second quadrant, so this here could be written as negative cos x squared. Okay. Now, all this is over. Now, this is cos negative 2x. Negative 2x is in the fourth quadrant because that's negative theta, so that can just, and cos is positive in the fourth quadrant, this can be written as cos 2x. And you have plus sine squared x. Okay, so simplifying a little bit further, negative sine x times negative sine x will give you positive sine squared x, right? So this here can be written as sine squared x, okay, minus. And this is negative cos x. When you square it, it gives you positive cos squared x, right? So because there's also a negative here, this here is just going to be cos squared x. Now this here is over. Yeah, this here is over. Now cos 2x is a double angle identity for cos. We can write this as cos squared x minus sine squared x, right? And all this is that there. Okay. Now the next thing I'm going to do here is I notice I can cancel out the numerator and denominator, but I can only cancel it if I rewrite the denominator. So what I mean by that is that this can be rewritten like this. Bringing out a negative makes the numerator and the denominator the same. You have sine squared x minus cos squared x, sine squared x minus cos squared x. Now this is plus. So in that case here, this whole thing will cancel that whole thing. So you're just left with negative 1 plus sine squared x, right? Which, as you know, is the same thing as saying sine squared x minus 1. And that's also an identity. And this identity gives you cos squared x. And that's the simplification of this expression. That's it. So moving on to the next question here, they ask us to prove that the identity 1 minus cos 2 theta over sine 2 theta times tan theta is equals to 1. So we have two identities here. We have the double angle identity for cos in the numerator. Actually, you have three. You have the double angle identity for the sine 2 theta and also tan theta, which can also be written as sine theta over cos theta, right? So we're going to be doing all three in one step, right? So the first thing I'm going to do in the numerator is I can write this as 1 minus, open bracket, 1 minus 2 sine squared theta. Now in the denominator, we could change this one to the only identity of sine 2 theta we have, which is 2 sine theta cos theta. And this tan theta, we can just write it as sine theta over cos theta. Okay. Now we notice here that we can cross cancel. Cos here can cancel this cos out. Now simplifying this for us properly, this can also be written as 2 sine squared theta, right? Because 1 minus 1 is 0, and this negative times this negative gives you a positive. Now all this over, we have 2 sine theta times sine theta, which would give you also 2 sine squared theta, right? And as you also know, that there can cancel that all out, and proving that identity will just be equals to 1, and that's it. So this question says determine the general solution of 2 cos squared alpha minus 3 cos alpha minus 2 is equals to 0. Looking at all this, this is a trinomial, right? If you don't really see it properly, think of it as cos alpha is k. So if I write it like this, 2k squared minus 3k minus 2, and that's something you can factorize, yeah? Okay, but we're just going to continue working with it as cos alpha, right? So factorizing this here can be factorized like this. This is going to give you, okay, so then solving for alpha, you're going to get, and on this side, you're going to get, now since cos alpha cannot be greater than 1 because that's your maximum value, we know that this answer is not applicable, or you could also say maybe something like no solutions can be gotten from here. But this one here, you can simplify it a bit. We move the cos over to the other side. This here is alpha is equals to cos shift negative half. What does that give you real quick? So we have shift cos negative half. So which is 120. Okay. So our answer for this will just be alpha is equals to plus minus 120 plus K360. And K is an element of integers. And this is one way to answer this question. You can just get it like this. The alternative way is you could first of all get the reference angle. After getting the reference angle, determine which quadrant causes negative, then substitute reference angle, and you get your two answers, right? If you're not 100% sure about that, there is a link in the description on my trig playlist. I did talk about a different way of calculating this, but this is a faster way and you will just get your answers real quick. But either one of them that you're comfortable with will definitely work. And that's it. Question 4. Now, this question says, in the diagram, O is the center of the circle, and EC is a tangent to the circle at C. DM is equals to MC, and OME is a straight line. Now, we're told that we should let O1 be equals to 2x. So you can kind of see 2x over here, right? This is O1 that we're given. A couple of important information. We're told that DM is equals to MC. That will come in handy. We're told that the line EC is a tangent. And that is more or less it. Every other thing, it's visible on our diagram. Okay, so let's get into the first question. So here says, give with reasons 3 angles that are equals to x. Okay, so looking at our diagram here, we see that A would be equals to x. And the reason why A is equals to x is angle at center is equals to 2 times angle at the circumference. Okay, that'll be your first answer. Now, another angle that is also equals to x is the bow tie, right? Remember the angles in the same segment? We would see that this D is equals to x, right? Yeah, if you're not 100% sure that's the bow tie, more or less. There you go. That's a horrible looking bow tie, but bear with me. Right? So those two angles are equal. Yeah. Which is called angles in the same segment. So let me remove this. So D, so we can say angle D is equals to angle A, which is equals to x. And the reason for that is angles at the same segment are equal. Okay. And finally, this here is x. OD and OC are both radiuses. Whenever the sides are the same, the angle they produce are usually the same. So for that reason, we're going to say that C2 is equals to D, which is equals to X. And the reason is isosceles triangle OD is equals to OC. And that's exactly what they wanted you to do for this question. Now in question 2 here, they asked us to prove that O2 is equals to 90 minus X. Okay, so we are asked to prove that this O2 here is equals to 90 minus X. Okay, so the first thing to do to answer O2 is to figure out what D2 is, right? And we can use it for the first theorem. Now this is 90 degrees. The reason why it's 90 degrees is M2 is equals to 90 degrees. Now this is the first theorem. The first theorem says whenever you draw a line from center and it bisects a chord, we normally say it is perpendicular. Okay, so we have M2 as 90. Now to get O2, since we have OMC is a triangle, we can calculate it using interior angles of a triangle, which gives us 180. Okay, so O2, M2, C2. So therefore, our O2 will just be 90 minus X, because obviously this is what we're trying to get. This one here is 90, like you see, and this one here is X. So using simple simplification, O2 will finally give you 90 minus X. That's it. Now for 3, they said prove that DOCE is a cyclic quadrilateral. So we're trying to prove that DOCE is a cyclic quadrilateral. Now, whenever you're proving a four-sided shape is a cyclic quadrilateral, there are 3 ways of proving them, right? So real quick, so there are 3 ways of proving them, right? The first one is this. So to prove a four-sided shape is a cyclic quad, we could either prove that the angles are supplementary, right? So we say A plus B is equals to 180. We could prove that the opposite interior angle is equals to the exterior angle, which in this case, let's say this A and this B. So we are saying like A is equals to B, and therefore this shape is a cyclic quadrilateral. And the final way to prove it is through angles in the same segment. So if I'm able to prove that this angle, like there, A is equals to B there, I could also say it's a cyclic quad. Now looking at all those 3 and looking at our shape that we're given, I'm inclined to use this one over here, the third one, angles in the same segment, because I can kind of see the outline of that shape and that can help me out, right? So if I want to prove this, I should either be trying to prove that this angle D is equals to angle E, yeah? Or I'm trying to prove that angle O3 is equals to angle C3. Now, if I can prove that these 2 angles are equal, or these 2 angles are equal, I could definitely say this shape is a cyclic quad. Now, diving straight into it, I would recommend we prove this here. The reason I want to prove D and E is because since I already have the value for D, I could just try to figure out what the value for E is. So if I can figure out what the value for E and it also gives me X, I could say it's a cyclic quad. Now, in the previous question, we actually found out that O2 is 90 minus X. So let's start with that. So to prove this, the first thing we'll start with is O2 is 90 minus X, and it was proven in the previous question. Now, the next thing we also see here is that C2 and C3 actually gives us 90. And the reason why it gives us 90 is because OC is a radius and EC is a tangent. And whenever a tangent and a radius intersect, the angle they produce is 90 degrees. So the next thing that we do know is C2 plus C3 is equals to 90, and the reason is tangent is perpendicular to radius. Okay, now the reason why I got these two angles is because I was looking at EOC, and if I'm able to get O2 and I'm able to get this angle of C here, I could use the interior angles of a triangle, which adds up to 180 to help me figure out what E is, right? In so doing, it would actually mean that E would also give you X, right? If you add all this, you get 180 degrees. So we can now say that therefore E3 is equals to X, and the reason is sum of angles in triangle. What is a triangle, by the way? Triangle EOC. There we go. Sum of angles in triangle EOC. That's where we get E3 as X. Now, since we have E3 as X and D is already X, we can say that this is a cyclic quad. Okay, so I haven't said it before, but I can also say D was X. We kind of proved it in the previous question. So we can now finally end and say that DOCE is a cyclic quad, and the reason is because angles in the same segment are equal. And that's it. Now B says, in the diagram below, M is the midpoint of QR in triangle PQT. T is a point on PQ such that PM and TR intersect at G. Now we have GH is parallel to PQ with H on QR. PG ratio PM is equals to 1:3. Now determine with reasons the numerical value of QH over HM. Okay, so from this information that we're given, this one over here, we understand that if PG ratio PM is equals to 1:3, because as you can see here, this is PG, this whole thing is PM, it would also mean that PG ratio GM would be 1:2, because if the entire length is 3, then from here to here would just be 2. So now if we write that in our diagram, we could say that this can be represented as 1K and this here can be represented as 2K. Now I'm using variables next to my numbers because that's not the actual value, just the ratio of those two sides. Okay. Now the question is asking us QH and HM. So we're looking at QH and HM, and we just found out PG and GM. So the triangle we're actually focusing on is this one over here. So since this triangle has parallel lines, we would know that we have to use the proportionality theorem. Okay, so the focus here would be the triangle PQM, and we know in this triangle GH is parallel to PQ, and because it is parallel, we also understand that QH over HM would be equals to PG over GM, right? We're doing this because of the proportionality theorem. We found what PG over GM is. This is like saying 1K over 2K, which as you know is just 1/2, right? So therefore, we know here that QH over HM is 1/2. That would be the numerical value of this fraction. So what we just got right now is that we found that the ratio here would be, let's say 2, let's call that X, and this here will be 1X, okay? Now the next question wants us to find RG over RT, Okay, so working with this here, we're trying to get RG over RT. So I would be recommending we use triangle TQR because we can figure out most of the values in this triangle here. Okay, so we focus on this. Next question will be this triangle like this. Okay, now the problem is for us to get RG over RT, we need the ratio of MR. Now, going back to the question, we were told that in the diagram below, M is the midpoint. Now, if M is the midpoint, it means that the distance of QM should be equal to the distance of MR. So looking at that there, that would mean that this here would actually be 3x because I'm looking at the entire distance there. Okay, now with this, I think I have enough information to answer my question. Triangle RTQ. We found that QH, HM, MR. QH, HM, MR. Okay, now this one here is 1:2, and this one here will be ratio 3. Okay, we knew this because we're told M is the midpoint. GH is parallel to TQ. Yeah, since we know that GH is parallel to TQ, we understand that this RG over RT would be equals to, so RG over RT will be equals to the entire proportion on this side, the entire length on this side, RH over RQ. So this here will be RH over RQ. Now for RH, I'm looking at the entire distance from here, which is just 5. So we can say this here would be 2x plus 3x over 6x. And as you know, that will just be 5 over 6. So RG over RT will just be 5 over 6. And this is exactly how they needed you to answer this particular question. This, we actually use the proportionality theorem. And that's it. So question 5. This question says the graph in the figure represents the curves of fx is equals to cos ax and gx is equals to b sine x. Now we say x is between negative 180 and 180. Now we have two graphs here. We have the graph of g and we have the graph of f. Now the first question, A, says determine a and b. Now this a and b comes from our equation here. So A comes from the cos x graph. Now, as you can see, the cos x graph is the f graph, so meaning this graph over here. Now, whenever you're trying to find your A, this A is in between the cos and the x. You use your period to help you get A, right? So A is 360 divided by the period of the graph. The graph of f, the period is 180. So this here is equals to 2. So A will be equals to 2. For B, gx is equals to b sine x. So we would say that the b is your amplitude. Looking at our g, which is this graph, the sine graph, you can get your amplitude from the highest point minus the lowest point divided by 2. So the highest point is a half minus the lowest point, which is negative 2, divided by 2, which is 1 over 2, right? So your B would be 1 over 2, but this graph is the reflection across the x-axis of the original sine x graph. So for that reason, it will have a negative. So our answer is negative half. So for B, write down the period of G. Now G is our sine graph and we can see that it completes a full circle in 360 degrees. So the answer for this would be 360 degrees. For C, they asked what is the minimum value of f? Minimum value is the lowest possible point, right? So the lowest possible point for our graph of f is this here, which is -1. So the answer here is just -1. So D, the question says how many values of x will fx plus half equals to g of x have in the given interval? Now, to answer this question, it would be best to rewrite it properly. So I can move the fx over to the other side, so I can write it like this: gx minus fx is equals to 1 over 2, right? So this is the same as that. Now, one thing you need to understand here is that how we look for it in our graph is that we're looking for where gx is above fx, okay? And the difference between g and f, the y of g and the y of f, the difference needs to give you half. Now, this question here doesn't actually want the x value. The question wants how many. So how many x values do we actually have, right? So there's a very different thing here. It wants how many values of x, not what is the x value, right? So we are counting it. We have to count it out. Okay, we have 1, we have 2, we have 3, something like that. Okay, so coming up to our graph here, we are focusing, like I said, where g is above f. So if I highlight it a bit, I'm looking at g is above f in this interval, and g is above f in this interval. So from this point of intersection, g is above until this point of intersection. Now the distance between them at the point of intersection is obviously 0, right? Because they meet at that point. There's no difference between g and fx. And now if you look at the highest point, from this highest point of g to the lowest point of f, we can say that the difference here would be 1 over 2. I got that because the distance from here to here is 1 over 2, and the distance from here to here is a full 1 unit, right? So the total distance will be 1.5 units or 1.5 units. Now, if the difference here is 0, and at the highest point difference is 1 over 2, we understand that between here to here, you will get at least 1 point that the difference would be half. And if you look at from 1 over 2 to 0 again, you will also get 1 point in which the difference would also be half again. From here, you should get 2 values of x in which the difference between g and f is 1 over 2. On this side here, we can see the lowest point is -half, and the lowest point here is -1. So the difference between this would be half unit. So this is also another x value that the difference is half. So we have 3 in total. So the answer we just need to give for this is just how many values of x with fx plus half equals to gx have in this given interval. We'll say that we just have 3 of them. That's it.